So, hey everybody, I'm Nathan. I'm going to be talking to you today about Yellowbrick and how we develop visualizations in Yellowbrick. Yellowbrick is an open source Python library for visualizing scikit-learn. Scikit-learn models, some of the other related utilities as part of scikit-learn, and we do quite a bit more. Here we go. So next up, I really wanted to thank the volunteers and you guys in the audience for being here. I'm one of the conference chairs here, and this was our speaker had to cancel, so I put this talk together. But this talk has been in me for about 2 years, and this is one of those things that we all kind of have, where we have something we want to talk about, the blog post never gets done, the talk doesn't happen, but it's like there, right? So again, I really wanted to thank John and really all the volunteers here. We have about 25 volunteers that have just made this such a smooth running conference. I've been to several PyDatas before, and it's really, you guys are the key to it. And you guys as the audience here. We have 300, 350 people coming here, and we put this on as a community for you guys, because at one point we were sitting in the audience, and when kind of the word came up that PyData was going to be getting organized, we said, let's do it. LA's ready for a PyData. As a committee chair, I want to say, feel free to talk to me about your experiences at the conference. Things that you love, things that could have maybe been a little better, and especially if you guys are interested in talking about getting involved with the next PyData, hopefully in the next year. And lastly, if you guys are interested in Yellowbrick, learning more, contributing, also come and talk to me. So outside of that, my day job, I'm a mobile backend developer at Farmers Insurance. We're in Woodland Hills local. It's a great place to work. I also run the Pasadena Python meetup, teach a lot of workshops on introduction to Python, very applied exercises in the public library and the community up there. And as I said, I'm the co-chair. So about this talk, I'm going to do a few things. I'm going to introduce you guys, you all, to Yellowbrick. As I said, a visualization package for scikit-learn. And then I'm going to go through the process of developing a visualizer. And this is something that in years of bringing on board new contributors to Yellowbrick, there's kind of like a process, a strategy I've learned for explaining to people how to combine scikit-learn, matplotlib, and NumPy into kind of a pattern that is stable, tested, well-documented, that folks can use downstream, pip install it. And normally, what I'm going to be presenting to you guys is something that I do one-on-one with individuals or small groups, and I've been doing it for several years. And remember when I said there was this talk in me that I wanted to share? This is it, with kind of putting all these kind of elements together. And then, and lastly, most of the people that I've kind of onboarded as contributors to Yellowbrick, they've kind of taken some of these approaches to developing and putting these kind of logics together and testing them and shipping them. They've kind of taken this approach and they've used it for other projects that they've used professionally or whatnot. So I have a couple notebooks with some code examples in there. I'm not going to do live coding. It's already been done. But just kind of going through the process. And it's in my GitHub right there, building a YB visualizer. So yeah. And then lastly, Yellowbrick, Yellowbrick Road. We have in our documentation and as a project, we're named after the Yellowbrick Road and the Wizard of Oz. So I'm going to include lots of photos. You'll see in the talk. So what is Yellowbrick? Yellowbrick extends the scikit-learn API to produce visualizations and captures common workflows that data scientists and other data professionals do. It's built with scikit-learn, matplotlib, and everything's kind of glued together with NumPy. And when I say common workflows, data scientists, we kind of think of it as like the model selection triple. There is, when you're approaching like a problem, number one, you're looking to engineer or find the kind of the feature set that is the smallest and most predictive. Next, you're trying to figure out the model or the model family that is kind of best suited to the problem. And then after you identify that kind of model or model family, then you're tuning the hyperparameters to get the best performance out of that. And we've found, and I'm sure those of you who have done this process before, that you might have a lot of scripts that are already doing this. You might have some visualizations or some kind of scoring metrics that you're doing that you kind of copy and paste and you apply to each one of these problems in your workflow. Yellowbrick, as we kind of designed it, is to capture these, make them really well done, generalized visualizations that you can kind of plug in to your problem, and you don't have to kind of rely on those scripts constantly. We have a really simple API, which, for those of you familiar with scikit-learn, might look pretty familiar. Step one, well, I guess you have to import stuff in Python, right? Next, instantiate the object, or here, this is one of our visualizers. Next, calling a fit or a transform method on it, passing the X and Y, the features and the target in, and then poof. So what is poof? I'll get into it later, but poof is essentially, Matplotlib already took the .draw function, so we had to use something. And being Yellowbrick, poof, this kind of sounds cool, like poof, here's your visualization. So you run that, and for this case, you get parallel coordinates. So this is one of our feature visualizers, parallel coordinates. This data set is for apartments if they're occupied or unoccupied. And this is a visualization to essentially quickly, you as the developer, or you as the one approaching this problem, to quickly determine the feature separation from this. So here for this data set, looking at apartments that are occupied versus unoccupied, you can see right off the bat, unoccupied apartments have a lower level of light. Occupied apartments have more light. CO2, that one's a little messy, but temperature is also another one. There's a general trend that apartments with lower temperatures are unoccupied versus the ones that are occupied. Kind of makes sense, but sometimes to quickly produce a visualization to kind of tease that out is very helpful in increasing, speeding up your workflow. Another visualizer, missing values. So this is one for horse colic. And this is one visualizing the positions of missing value by feature. And right off the bat, my first observation here is that there's some change in the data, maybe in the data collection technique. So right after the position by index after maybe 90 or 100, things kind of change. Doesn't that seem pretty predictive to you guys right off the bat as like a first step and seeing how you're going to select features? Another one, this is one of our regression visualizers for residuals. So here you can kind of see where the predicted outcome or value and the error there might be areas of your data where there might be clusters of errors or things where the model doesn't fit particularly well. Lastly, this is a pretty cool one. For discrimination thresholds for binary classifiers. So this one is visualizing kind of an old data set, ham versus spam. So simply, if an email you get is the classifier determines is it ham or it's spam, and this discrimination threshold in this one is logistical regression, what is the decision threshold of probability that it is spam or ham? On the lower X. And as you go through each one of those thresholds, how is your model performing? Recall, precision, Q rate, and whatnot. And here, based upon your business needs, maybe you're making a binary classification for if someone has shown an ad or not. You can know based upon what you're trying to optimize for. Is it precision or recall? What is your business sensitivity? To kind of very quickly hone in to where you want to set that threshold. So that's just kind of a very quick introduction to some of our visualizers. So now I'm going to kind of shift into the process of developing a visualizer, and we're kind of going to go into, after you develop it, how we kind of package it and ship it. So what is a visualizer? A visualizer is a generalized unit of work that in Yellowbrick produces a matplotlib visualization. Under the hood, as I said before, it combines the business and display logic for fitting a model and then drawing whatever kind of outcomes that we want in a visualization, and it's kind of glued together with NumPy. So getting even deeper, in Python, a visualizer, it's an object. Well, that's not fair to say because everything in Python is an object, right? And well, a visualizer is a defined class. So a defined class that it's instantiated, it has methods and properties, and we use that kind of class approach for how we organize that logic for developing a visualization, or, in another word, developing a data product, kind of visualizer. And this kind of pattern, or organizational approach to code, allows us to reuse it. Python, we have inheritance, so we can use other methods and properties that we inherit from. It increases understandability because you have logical pieces of code that may be a little more oriented to fitting and modeling versus that is drawing. I'm going to go through examples in a little while, and you can kind of separate them appropriately. And lastly, as soon as you have your code that's properly separated and clean and understandable, it makes it a lot easier to test and to document, which we will getting in towards the end. So the Yellowbrick Visualizer API, there's roughly 4 components to this. This is a little more simplified, but as there's classes, we have an init method, which generally is for configuration, and in most of our visualizers, that includes the model you're passing into initialization. The fit method, where the transformation logic or the actual fit modeling goes. Drawing the plot based upon the outcomes from fit is all done by matplotlib. And then poof finalizes the plot and any other kind of like display presentation logic. And last to say, in our model visualizers, we wrap the scikit-learn model inside of that. So after a visualization is done, then a user has access to the model. One of the things that we're actively developing is other modeling libraries like TensorFlow, Keras, et cetera. Well, not TensorFlow, but other similar ones that use the scikit-learn API, passing that estimator into a visualizer to create visualizations and help data scientists better understand their models. So here we go. Let's build a decision boundary visualizer. This is kind of like the 101 that beginning data scientists in classes, they normally kind of see. What is machine learning and kind of what's going on? So as a disclaimer, I borrowed this from scikit-learn's nearest neighbor classification example. And this was also one of the first ones that about 2 years ago, I took this example, and as I was learning the Yellowbrick API, took this code and transformed this into the Yellowbrick API. So anybody want to take a shot? What's going on here? I'm sure you guys have seen this before. So we have boundaries. Anybody? Yeah, great. So, exactly. So this, under the data set I'm using here is the great toy set iris data set. We've all seen this before. And this is, what this is representing here, this is k-means. And after we train the model, this is kind of how the model sees the world, or at least in this kind of space with the x and the y that are being passed into it. So for here, this boundary right here, it sees if you pass in one object to predict, this is where the model is going to classify it as, versus this kind of blue area, this is where the model sees that, and anything that's in that space is classified accordingly in green. And you can see here how actually the model for each one of these individual instances kind of classifies it. Yeah, so as we're building this, I'm gonna kind of go through my common workflow for building a visualizer, and I'm sure many of you guys, many of you all, this is kind of a common approach you have from experimenting with getting your outcome, and then eventually refining, refactoring it to make it so you can reproduce and share it with the rest of your team. So step one, it's usually to get something working. So I can't really see this, but let me see if I make this a little smaller. So usually it's something where you're loading, you're cleaning the data, and after you have the data, you're setting your x and y per the scikit-learn pattern. And you set up some kind of matplotlib. You say, hey, this is the color scheme I want to use. There's noise everywhere because you're trying to see the outcomes. You pass in maybe one or many classifiers to it or whatever you're trying to do. It's kind of noisy. Then you say, okay, I've trained it. Now I want to do some more of the drawing logic. There's no comments. You're not really sure what's kind of going on here. This is like many of the common notebooks that I do. Initially, I see some kind of nods. You're like, yeah, we've been here before. And then eventually, you get to drawing something. And you're like, whoa, it works. Right? We've all been there before. Last week, it was the same thing. And then when you kind of step back, and you're like, this is really cool. I got this to work. And then for some reason, your kernel dies or whatnot, and you hit restart and run all, what happens? You kind of just broke everything. And oh, wait, you forgot to import the data sets, API or module or whatnot. Things are out of order. As you kind of saw here before, the state on notebooks, it's not linear. It's kind of skipping around a lot. So step number one in Yellowbrick, my common development flow, like for many of you, is getting something working, learning, quick iterative development. And the key with visualizations, you rapidly have to get this feedback of how's the visualization looking, is it working, am I missing the title, or this or that. Cons, obviously, it's messy. It's iterative development. And obviously, it's not ready to ship. Step two. Step two, this is when you come back and you're like, whoa, things weren't working before. How can I refactor it? Maybe you're following PEP8, or maybe you're following your own kind of like style guide. And you're like, okay, I'm gonna write some good Python code. I'm gonna put all my imports at the top, right? PEP8. Then you're like, I'm going to make sure the model that I found that is the best solution for this problem, I'm gonna really clearly put it somewhere else, separate these concerns a little bit. Same thing for the data. Maybe you've already done that. Maybe you're getting that from a separate system or whatnot, but that is something you kind of separate, you refactor out so it's really clean, it's not kind of splashed everywhere. Same thing for configuration. Maybe it's different from an input. Maybe it's just like, the light how you're styling something, or these like little optional parameters that you kind of make. Another step in that too, or another thing is, you might change variable names. So what was H before? H was a single letter variable that me, developer, I look at that, I'm like, what is H? I guarantee in 2 weeks or 3 weeks, I'm gonna have no idea what that is. I'm seeing some nods, so yeah, we've all been scarred by that before. Then you separate it out and you're like, okay, this is all the modeling code or all the scikit-learn code. Let's keep this nice and clean, make it understandable. Draw for everything you're doing to produce your visualization, or maybe it's some other kind of output. Maybe it's going into a web page. At that point, you're going to kind of separate into a logical component. And hey, look, it works. Not even does it work, but it's clean. You can understand your coworker, and maybe it's something you put online. Or maybe you can share it online for a project that you've done. Step 3, applying these components into a pattern. So this is kind of in Yellowbrick. I skipped a slide right there. I already talked about that, though. Applying these components into a pattern. So for me, as I'm developing a visualizer, and maybe whatever projects you're working on, there's usually kind of like a pattern where things kind of fit into it. In this case, for Yellowbrick, I'm still using the Jupyter Notebook because visualizations require very rapid feedback on how the visualization is looking, how it's performing. In this case, I'm going to inherit from a base class we have so we can access those other methods and properties. And I'm going to add and adjust the code. I'm going to adjust the code that we originally had before and put it into this like bigger class, to how it would work in our API scheme. So applying the components into a pattern. And I'm just going to go this kind of very quickly. So inheriting from, in this case, the Yellowbrick base visualizer, which contains a lot of common methods and properties. In the init method, I'm putting all of the kind of configuration. I'm putting also, as this one is visualizing a model, I'm also passing that model in as part of the instantiation. And then I'm doing, well, setting these other methods and properties on it. In the fit method, I'm placing all of this, as we said before, fitting, scikit-learn, maybe some transformation code in here as well, making a couple little changes so that everything is kind of self-contained in this class. And then lastly, or next, going and draw. So all this drawing, display logic, putting this all into display. This is almost exactly the same code that we went 2 steps ago doing our iterative development, then we refactored. Now we're putting it into an API or a clearly documented structure for how this code is going to live and how it's going to be used. And lastly, I didn't put this in there before, but the proof method in the Yellowbrick API calls finalize. And finalize is where you get the nice stuff like setting the title for your visualization or also the legend. And just for convenience, I put a fit draw poof method on this. So instead of calling all 3 or all 2 methods, you just have to call 1. And as you can see, fit draw called fit, draw, and poof. So now that we've applied this into the common pattern, we're going to go back and kind of go back through the method and just kind of test that it works. So first, we're setting our input data. We're instantiating our model. And we're running the visualizer and calling fit draw poof. And hey, look, it works. Great. We have something that's reproducible. We've kind of captured all this logic into one place. And then we got a visualization. So what next? What do you guys do next? Well, yeah. Mm-hmm. Yeah, great question. So one of the things we can do, so these are, in Python, these are optional arguments or default arguments. So if we wanted to change these colors, we could just pass in light colors here. I don't have this set up, but light colors, and then put something in here, right? So, amazing question. That's what we want to do in Yellowbrick. Any other suggestions? Okay, I'm just going to go. So what I would want to do next is, hey, we got this working for nearest neighbors. I want to see how another model sees this data. How does it work? So what am I going to do? I'm going to, well, yes, it's smart. Yes, it works. I'm so smart. Common reaction, right? So I'm going to test this with another model. So I'm going to import a random forest, instantiate it, pass that model in here again. Hey, look. We have, can you guys see that? We have this visualization here. This is how that model sees the world or sees that data set and how it's going to classify accordingly. As it's a random forest, you would kind of assume that however it's interpreting the data, it's made certain rules that at 2.5 or whatnot, everything on the X label less than, let's say, 4.8 is going to be this, that. So clearly, if we pass more models into this, we can reproduce this visualization and understand the model and kind of its rules versus looking at a list of numbers and kind of trying to make a determination based upon that about how the model is performing. Cool. So now that we've applied this in the pattern, it works. Now what? What do we normally do? What do you guys normally do after this? You got something working, something's performing well. Okay. Someone gets a gold star. But that doesn't happen everywhere, right? But what do you guys... Okay, the answer is write test, document, make it more stable. But in your common workflows, I've worked for several teams. Writing tests, sometimes there's not time, right? Ship it, there you go. When I was working in journalism, it was just like, hey, good enough, let's get it on the site. Our audience needs to see that. But then, here comes the question. It was raised before, to test or not to test? So again, Wizard of Oz here, and this is a flying monkey right here. So the question is, releasing something in Yellowbrick that's going to be consumed by downstream users, or it's going to be used by paying customers, we need to make sure this stuff is solid, right? Maybe it's internal, maybe it's a prototype, maybe you show your boss, maybe you don't put tests. But the lesser evil, I would say, is writing some tests. Tests take a little time, but quality, stable product, something you can stand by, is great. So why write tests? As I said, stability, controlling complex systems. This is a trivial example here, but in some of the pipelines out there, there's lots of data transformations, multiple models, all kinds of stuff, right? And humans make mistakes. Sometimes we make a change, things break, we don't go through that manual testing process to confirm everything is working correctly. Sometimes Git just gets in our way. How many times has like a merge conflict broken something really important for you guys? All the time, right? Documentation, documenting how your system works. And what I say to my bosses at work is as soon as we have a stable system, we write some tests, we know it works, we can go faster. We can build more complex, cool things. So here's a simple test case. This is our radial visualizer, and this plots points along axes around a circle to detect if features are separating. So what do you guys notice about these two visualizations? It's the same data, whatnot. Well, one is rad, has a circle, and one is not rad, right? This is a git merge conflict. It's one line of code in one of our visualizers. And the question is, if you have 30 visualizers or you have a massive product, massive data product, you can't go and visually inspect every single one to make sure it works. So what happened? Well, there's a bug, a flying monkey got in our code there. So how to test against this? So visually inspect before every release, mock all the things, which mocking in the Python world is, it can be complicated. There's a learning curve. And while I love matplotlib and digging through its internals, writing test cases and mocking that, I'd rather do other things. Here's an example of mocking matplotlib. I did this for Yellowbrick before I found a better way. Mock, legends, whatnot. And there's many ways to do this. There's a simple example. You're just testing that something's called. And we're doing visualizations. We're not testing that something's called exactly. We want to find a way to know that our visualization is drawn correctly and consistently. So path to a better way. A couple years ago in PyCon 2017 in Portland, this is a big issue in our growing library. Simply the sprints, I kind of thought maybe someone else has had that problem before. So I did what I should have done in the beginning. I just read the documentation. Right? Read the docs, guys. But assuming you guys developing these features, the people the libraries you're using, most likely they've encountered these problems before. So matplotlib, they have an image comparison test that in our group of core contributors for Yellowbrick, we're like, how do we do this? How do we do this? And we just had to read the docs and it was there. It's great. So this is what they do. So it's under the hood. They call it an image comparison test. And they compare a baseline image against what you're actually producing in that current time you're writing the test. And it produces diff file, which as a human, visually, you can clearly see the difference, right? I can't see it from here, but I'm sure you guys can see it in the back. And includes a scoring metric. So if it goes pixel by pixel, and if the images are different, it returns a error metric, and with a tolerance to say if it's greater than this, well, your test is going to fail. And pretty simply, I used what I found in matplotlib to add this to our test suite and just do an image comparison test. So testing the actual visualizer itself, putting it in there, and asserting that it meets the baseline image. Yeah. So I'm sure some of you saw this and you're like, whoa, that's a lot of hand artisanal data right there. So generating test data for scikit-learn. These are some of the things that we're kind of running out of time. These are easy utilities that when I've explained this to people before, hey, there's these easy things for writing tests in scikit-learn or matplotlib, people just need to know about them. And that's kind of like the second half of the talk that I just wanted to kind of explain to you guys. So this is artisanal data, right? Handcrafted, hand-coded, but can we do better? Well, the scikit-learn developers encountered this problem. They have a dataset API for make a classification dataset. They also have one for making a regression dataset. Also for making blobs for clustering as well. Plug it in. Just don't forget the random seed. Can anybody tell me why? Yeah, we want our tests to be deterministic. So you write a test, they're going to behave the same way each time. So putting it together, now, when we write a test, kind of very similar to the pattern we followed before, we instantiate the model, we create our test data, we pass it in to our model, we call our method, we do other kind of testing the features, we didn't talk about that, making sure other attributes and properties are there, and then we do an image similarity test to make sure what was drawn versus what the baseline, it's stable and it exists. Also, don't have a lot of time, but NumPy, there's also an assert array equal testing method you can use. This is stuff that you just got to know about. It's going to make your testing a lot easier. So to summarize, clean, well-structured code is just to start. It's going to make it, I don't even have to explain this to you guys. It's just going to make your life easier. Read the development contributor documentation. These libraries have encountered the same problems that you have before in the past, and they've most likely come up with the solutions. And sometimes you're going to have to dig into the source code. Set up and follow patterns, APIs or whatever, to make your life easier, understand how code is structured and where it lives, and share what you've learned with others. I've had this talking to me for a couple years, and the reason that I come to conferences like this is to learn from other people, and I'm really happy that I had a chance to share with you guys. I have one more slide after this. Yellowbrick, we're looking for contributors. Come talk with me. And really important, I just want to give some shout outs to my mentors. First, Rami Chowdhury, Rebecca Bilbrow, Benjamin Benford. They really spent a lot of time. They're my friends, but I feel like they're mentors. This journey I'm on, you guys are on too. You know, it's a community, help each other. And to all you guys at PyData, attendees, committee, NumFOCUS, thank you guys so much. And to Yellowbrick, users, contributors, maintainers, this was us at PyCon 2018 sprints. Very successful sprints, tons of PRs, onboarding new people. It's a great community. Anyway, that's it. Thank you, guys.
All right, so we've got about 10 minutes for questions, if anybody has anything they'd like to ask Nathan. Yeah, I'll come around with the mic.
So can you feed in an already fit model into the visualizer workflow, or do you have to, that seemed like part of it?
It just depends on the visualizer. I would recommend just looking at the documentation. But yes, generally our visualizers will accept fitted models.
Why does something like this need to exist outside of Matplotlib as opposed to inside? Like, why does it need to be an independent package?
That's a great question. And I think, you know, part of it is, I think it's just how this project grew. When Matplotlib got started, it, you know, scikit-learn didn't exist, and this exact problem didn't really exist yet. I would say that part of it is just, you know, kind of the open source community and kind of figuring out ways to kind of collaborate and how to kind of maybe join or, you know, better collaborate. So it's really just kind of a community question, I think.
All right, anybody else? All right, well, Nathan, thank you so much for your talk on Yellowbricks.
Okay.